All right, so we said, here we go. We're going to talk about writing equations, graphing and writing equations of a line, okay? So if you want to title you can title your notes, graphing.
Didn't you just say writing equations?
Yeah, you just said graphing. Or you said
There you
just
go.
writing.
Slash writing
Writing the wrong.
equations
You're concentrating so hard. It's great.
from lines.
Okay.
That's
I'm
like,
gonna go ahead and deem that calligraphy.
it's pretty gross, dude. I have a hard time writing with this thing. I don't know why. All right, so that's what we're going to do today. Okay. Okay, when we graph a line, we can do a couple different things. When we graph a line, we could have 2 points. So our first example, let's say we're given the points -6 and 4, and we're also given the points 3 and 10. Okay, so if we're given those points already, it's easy to graph this. All I have to do is go to those points, -6. So 1, 2, 3, 4, 5, 6. Go down or up 4. 1, 2, 3, 4, and it's going to be somewhere. It's going to be somewhere in here. Okay, so then I graph my point. There's 1 point there. And you can label your point. Yeah, this is all about graphing, so you're going to have to graph quite a bit. Now, whenever we graph anything, you need to use graph paper. Okay, so homework and all that stuff, if it's not already provided for you, you need to provide the graph paper. So that's -6 and 4, and then we're going to go over 3. I have to make this a little... Okay, over 3, up 10, which is going to be that up right about here. Okay, so this is your 3 over, 10 up. So I was given 2 points. So whenever I'm given 2 points and I want to draw a graph, then all I have to do is take those 2 points, because there's a postulate and a theorem in geometry that you'll talk about that basically through any 2 points is a line. But what I'm going to do is I'm going to go through here, and I'm just going to draw my line to those 2 points as best I can. Obviously, I messed that up a little bit, but close enough. And then you need to make sure that your line has an arrow. When you're doing a line is what? It goes on forever. It's infinite. It goes on forever. Okay, so then you draw a line going that direction, or like that forever. Okay.
Does that jump both ends?
Yeah, it needs to be on both ends, but my graph's going off the paper, so you can't see the other arrows. But yes, very good question. So the graph is going to go on both ends, or the arrows.
Do we have to always label the points?
No, you don't have to always label the points. I was just kind of showing you what the points are. It's good practice to label the points, but it's not necessary. Now, if I want to find the slope, what's the slope?
Rise over run.
Okay, I could do rise over run.
Up 6 over 9.
Whoops. I could do rise over run, which you said is, let's see, if I go up 1, 2, 3, 4, 5, 6, right? So plus 6, and then over. From here to here, it's how many spaces?
6.
Yeah, from there to there, it's 6 spaces because you're at -6. So -6 to 0 is 6 spaces, right? So this is 6. And then from here to your point is what?
3.
So 6 and 3 is what? 9. Okay? So your slope is 6/9 or?
1/3.
Yeah, or 2/3. Divide by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So your slope is 2/3. Okay, what's our y-intercept? Well, wait, hold on. How else could we have figured out our slope?
Looked at the coordinates.
Okay. So you said look at the coordinates you were given, and somebody over here said the right answer. Slope formula. Okay? Which is the exact right answer. So I could have taken these points, -6 and 4, and 3 and 10, and I could have plugged that into the slope formula, which is what?
y2 minus y1 over yx, or x, y2 minus x1.
So I could have done that, right? I could have used that formula. But anytime I'm given a graph or I create a graph, I always like to personally just count because it's a little easier. Okay? But you could have used that as well. What's our y-intercept?
Or what?
So far we found m is equal to 2/3.
9.
What is b? What's our y-intercept?
9. 8.5.
Okay? So is that it?
Yeah.
That's where the y crosses the the graph crosses the x-axis, or the y-axis, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and almost a half. So 8.5 would be correct there. So our y-intercept would be 8.5. And if I wanted to write an equation for this, how would I write the equation?
Y equals 2/3 x plus 8.5.
And that's it. Y equals 2/3 x plus 8.5. So here's all the information, all the relevant information I just got out of that. Okay, now I have basically the same 3 or 4 people answering all the questions. I need to know, does everybody understand what we just did there? Okay, you have a test over this, and here's the deal. I want to make sure that I'm very clear with the fact that the first 6 weeks is extremely easy. Okay, it's how regular classes are a lot of times. It's how Algebra 1 is. It gets harder. You cannot sit there and pretend like you know when you don't know. Only reason I say that is because that's what so many students do, and then they realize, oh, wait a minute. We're into a new chapter, no big deal. I'm so glad we're done with slope because I had a hard time with that. And then you realize, oh, the next chapter, Unit 4, oh, we still have to know how to solve for slope. We still have to know how to write equations of a line. We still have to know what y-intercepts are. Algebra 1, you never stop using the stuff that you've done before. Does that make sense? Okay. That's math, period. That's not just Algebra 1. That's math, period. So you need to make sure that you understand what we're doing here. If you have any questions, either ask me now during class or you can ask me in tutoring. But please don't be intimidated by the fact that I have geometry students in here. You can ask me or do anything you need to while I'm in here. Okay? They are filled, but you just kind of have to do what you got to do. And I'm here after school, 4 to 5 every day, except for Fridays. All right, any questions on this? Yes?
Oh, not on this, but
What?
Mariah, she's going to have to sit here, so I'm going to sit on the floor.
Yeah, but she's probably not. All right, here you go. Moving on. Okay, so how do we just graph that line? How do we graph that line? Yeah, I'm just recapping. So, because remember, this is about graphing and writing equations at the same time. So I want to make sure we understand. So that particular example you did was given 2 points. You might write on your example, given 2 points. I was given 2 points, I plotted those points, and then I was able to graph that line. Okay? Now, what if I'm given a point now? And we'll say that point is -5, 5. Thank you.
Wait, what did you just say?
So what if I'm giving a point now, and we'll say that point is -5, 5, and we're also given a slope, m equals 2. How do you think I graph this?
Graph -5 over 5, and then go up.
Graph -5 over 5?
The slope is 2 over 1. So
Okay, let's go one step at a time. What do I start with?
-5.
What do I do with that -5 over 5? Somebody else. You're right. We start with -5 over 5. Preston, what do I do with that -5 over 5? Or -5, 5. What is this? A coordinate. What do I do with it? I graph it. I plot that coordinate first. So that's what I'm going to start with first. And I think that's what you were trying to say, but you kept saying 5 over 5, throw me off. So I'm going to go over negative 5. So 1, 2, 3, 4, 5, negative 5, and then up. 1, 2, 3, 4, 5. It's going to be somewhere in there. All right, now, what do I do now? Do I graph the slope?
They use the slope to figure out where you're going to, what the point is, so you can figure out the water.
Hang on one second. What do I need to do with my slope now in order to continue to graph? Because we're obviously you use the point. Now we need to use the slope. What am I going to do with it? And Nathan touched on it a second ago, but I want somebody else to tell me. What are we going to do? Can I use the slope like it is too? Does that help me with anything? Yeah, I need to go ahead and put it into a fraction and make it 2 over 1. This is one of the rare times in math that you don't reduce it. You actually make it bigger. So I'm going to change this to 2 over 1. What does that give me when I change it to 2 over 1? It gives me a rise and a run. Somebody other than the same old, okay? How am I going to use my rise over run now? Okay, Ruby said I'm going to rise 2 and then I'm going to run 1. Somebody else tell me from where? Where am I going to rise 2 and run 1 from? Say again, who said that? Over here, somewhere in this front, lady. The point. I'm going to rise 2 and run 1 from that point. Okay? So it gave me a point to start with. Take that point, and now I'm going to say, okay, I'm going to go up 2, 1, 2, and over 1. And here's my point. Up 2, 1, 2, and over 1. Somewhere along these lines, okay? Huh? Just so I can try to get it closer to the line. Unfortunately, these pens are terrible. I've never found one that's small. Okay, so now I have points. Whenever they're close together like that, I like to try to get 3 points on there or 4 points. The more points, the straighter your line's going to be, the better your line's going to be. So now I have points. Put your arrows at the end. Okay, indicating it goes on forever. And now let's go ahead and find out some information. We already know the slope, right, because it was given to us. The slope was what?
2.
So m equals 2. What's our y-intercept?
15. It should be.
How did you get 15?
You just kept on doing rise over run.
Okay, so he kept on doing rise over run until he got there. I'm going to show you a trick that if you... Does our graph cross the y-axis right now? Is it going to cross the y-axis? Yes, at some point it will cross the y-axis. So let me show you a trick, okay? If I don't want to go through the hassles of finding all that stuff, I can still use this, and it's going to take a little bit of math work. I can still use y equals mx plus b. Now plug in what I know. Do I know a y value? I don't? 5. Wasn't I given a y value?
Yeah.
Yeah, so 5 is my y value. Do I know m?
Yeah.
Yeah, m is 2. What is my x value? Negative 5, right? Plus b. Okay? Can I solve for b now? Yes, I absolutely can. So 5 equals, what's 2 times negative 5? Negative 10. Plus b. Okay, what am I going to do now? Add 10 to both sides. So 5 plus 10 is? 15. So b equals 15. And that confirms what Nathan already told us. And Nathan, now again, it's all up to you. Nathan obviously had enough room on his graph just to keep going up and over, up and over, up and over, up and over until he crossed, right? And that's one option. And you can do that. But there's going to be problems as we move through the year that it's not going to be that easy to go up and over, up and over, up and over. Okay? So in that case, we can just plug into that equation and solve. Anybody have any questions over that? Now, what's our equation of the line? What's the equation of the line? Y equals 2x plus 15. Please understand that the equations always look like this. They always have y is y, x is x, and then 2x plus 15. Okay? This is never your equation of a line. I see students do this all the time. 5 equals 2 times negative 5 plus b. That's my equation. It's not. It's always got a y and x. Okay? Any questions on that? So we've already learned how to graph using 2 points. And then now we've learned how to graph using a point and a slope. Okay? What if I'm given this? What if I say, okay, I'll give you this point. Not that. It's 3, 0. And I'm going to tell you that my m is undefined. How do you solve that? What do I start with? Yeah, start with graphing the 3, 0, right? Start with graphing the point. Always start the same. That doesn't change anything. So go over 3 and up 0. So that's right there where? It's on the x-axis, right? So over 3, up 0. Okay? What does an undefined line mean? It's vertical. So what do you think I do now? Okay, I draw a line that goes straight up and down where? Okay.
It goes on that point.
That goes through that point. It gave us that point for a reason, right? So we draw our vertical line. Going through that point. Does everybody see that? So whenever it gives us a line going through that point, whenever it gives us a point and tells us undefined line, we have to first know, hey, it's undefined, meaning I have a vertical line. Okay, where does that vertical line go? It goes through that point. And then it goes straight up. Just like that. Okay, any questions on that? Yes?
Would the equation just be y equals undefined? Okay.
We're going to talk about that now. Now, the equations for this are different. Okay? Do we have... Okay, let's look at this. Let's look at the slope. We said our slope is undefined. It's right here, right? What is our y-intercept? None. You're never going to have a y-intercept. Okay? So if you're not going to have a y-intercept, it's out. Now, what kind of line do we have? It's a vertical line. Which axis is it going through? It's going through the x-axis. So the easiest way, and I could go through a proof on this for you, but I'm not going to take the time to do that. It'll just confuse you. The easiest way to write the equation is for every vertical line, you might write this in your notes. For every vertical line, the equation is x equals something. Okay? And it's some value. So what do you think x equals here? 3. So the equation of this line is x equals 3.
Is Preston here?
Yes.
Yes.
So here's the relevant information we just discovered.
Okay, gotcha. Preston over Slabowski.
Zablowski. Okay? What's the equation of this line? Okay, so here we go to 1, 2, 3, 4, 5. Okay, so x equals. Okay, let's do one more. What's the equation of this line? X equals 0. Very good. Any questions on that? And that's just simply memorizing. Simply memorizing. It's very simple, but students have a hard time with this every single year. Okay? All right.
Is that all for those?
No, we have one. We have at least one more example. No, we have a couple more examples. Okay. 9:27. Okay, let's say all right, let's say I'm given the slope m equals negative 2/3. And the y-intercept now of b equals 3. What's my equation right off the bat? Somebody else. What's my equation? Let's see. JC, what's my equation? So y equals negative 2/3 x plus 3. Anybody disagree with that? No. Okay. How do I graph this?
The y-axis. The y-axis.
Do you have a point?
Yeah.
Yes. If you're ever given a point, no matter what that point is, start with that. What's our point? 0, 3, right? Because it's a y-intercept. So I'm just going to go, and all I have to really do is go 3 on the y-axis, right? And that's what Nathan was saying. Go 3 on the y-axis. 1, 2, 3. And plot my point. Now what am I going to do?
You're gonna rise over run.
Yeah, you're going to rise over run. So I already have rise and run. What's my rise? What's my run? Could my rise be positive 2?
You could change.
If the 3 was negative. So my rise could be positive 2 and have a run of negative 3. And I'll show you that here in a second. So what am I going to do now? Okay. Go down from where?
From 0
From the point, the y-intercept, right? So go down how many?
to
And then
the right.
to the right, 1, 2, 3. And I'm going to plot my point. Okay? Now, I just said, could it be a positive 2? And we said, yes, right? Okay? I could go up 2, but then I would have to go which direction with 3? Left now.
You would still have a straight line.
And there's my point for that. Is it still in a straight line? Yeah, am I still going to have a straight line? Absolutely. It's the same thing, right? How come I didn't go negative both directions? You can have negative over negative, but what does negative over negative mean? Positive. And that would change my line, not the shape, my line. It would change my line, and so I need to make sure my slope goes negative. If my slope is negative, which direction is my line going? Yeah, it's going downward. Okay, so here's my line right there. Maybe. Okay, so there's my line right there. Now, the next thing we need to throw in the mix here that kind of is confusing is the domain and range. What's the domain? Okay, let's recap. What does domain deal with? The x values. And more specifically, and this has been kind of my fault for not stressing this, it is all of the x values for a function. It's not just some of the x values. It's not just the x values you see. It's all of the x values or the possible x values of a function. Okay? So what are the x values for this function?
-3, 0.
So he's telling me that -3 is an x value, and it is. And then he's telling me 3 is an x value, and it is. 0 is an x value. What else? What if I just said, hey, I'm going to put a point here. Is that point on the line? Is it part of the function? What about here? Well,
Put every single one.
Yeah, sure. Yeah.
are all those points on the line? Yes, right? Okay, if I keep making my line out bigger, are those points going to be on the line? So what are my x values? All of them. Say again? All real numbers. She's all excited back there. All real numbers. Okay? Now let me explain that for the rest of you who aren't so excited jumping out of their seat. Okay? All learning, yeah. All right, here we go. All real numbers, for all of you going that, all of them. All of them. We don't have an all of them option in math. Okay? When you every number, we call them all real numbers. Meaning that forever and ever, is this x value going to be used? Yes. Okay, all the negatives are going to be used. Forever and ever, is this x value going to be used? Yes. So that means that there's no x value that's not going to be used. So it is all real numbers. And when we do that, we write it like this. And I'm terrible at this. It looks like an R. But that's all real numbers. That's a symbol for all real numbers. So our domain is all real numbers because it incorporates everything.
How did you just? Can I turn off my phone?
Sure. Okay?
Wouldn't you have to follow the rise of the run though?
Yeah, but if I rise and run, remember, okay, -2/3, I could go from several different points. So if it's on this line, it'll follow rise over run somewhere. Between some 2 points, it'll hit that. Okay, so every one works. Okay? What about range? What does range deal with? Okay, and again, all of your y values, not just some of them, not just the ones that we plot, that's what we're figuring out here. It's not just the ones that we put on because of the rise over run, it's all of them that are on that line. Okay, so what is my range? All real numbers.
Is that like the answer to ask that question?
Yeah. So that's so Jefferson just asked, is that the answer if they ask that question? Yes. There's our domain and range. And that's a harder part. Now these are easy. Now I'll explain that in just a second why these are easy, because they get harder than that as far as domain and range go. Now real quick, I want to show you something that you don't need right now, but you will use as we move forward. One of the ways I check for domain and range is I look to see, is there an ending point? Is there a minimum? That means I go down here and say, okay, is there a minimum x value? Does my x value stop? No, because of that arrow, there's no minimum x value. However, if I were to erase this arrow, and subsequently the highlighting, okay, do I have a minimum value now, x value?
Yes.
Yes, okay, that makes a difference when we're talking about domain and range later on. Okay? And then once I find my minimum, then I'll look for a maximum. And I go this way. Do I have a maximum? Well, you have an arrow. So there's no maximum there. Okay? So that's for my domain. Now my range is similar. Do I have a minimum? Meaning down here now. Going that way. Again, I don't have a range because I have the arrow. Okay? Do I have a maximum? I go up here. In this case I do because I erased that endpoint, right? But what you'll find out is if this is not an arrow and this is an endpoint, your domain and range are all in that box, right? So your x value has a minimum of negative whatever and a maximum of positive whatever, and all of your x values are in between those 2 points. And I want you to kind of let that sink in your head. Same thing here, going up and down. All of your x and y values are in between those 2 points. Okay? And that's all I'm going to tell you for now, because then what's going to happen is we'll talk more about that when we need it more. But I wanted to kind of give you a little brief introduction. Okay? All right, any questions on that? Okay? Let's look at another example. Now you're just given an equation. And this is what you're going to do more often than not. Okay? Y equals 4x minus 5. So now I'm just starting with an equation. Yeah. Yes, yes. For onions, yes. Oh. Funny you should say that. Jefferson, are you in the band?
Yes.
There is an onion in the band. Her last name is Maxie, Miller Maxie. Okay, now, if I'm given an equation, what do I know?
The N and B.
Okay, m equals what? M equals slope, which is 4. I'm going to graph, so what am I going to need to do with that? Okay, so how do I create that? 4 over 1. So like Savannah just said, rise over run. Okay. Somebody other than the same old, let's see. Gracio, what else do I know? The B. Okay, Alexis, what is the B?
5.
Is it 5?
Negative.
Negative 5, right?
Yep.
Negative 5. Okay, so now I have all the information I need in order to graph. What do I need to do? Start at B. Or always start at your point, right? So what's the 1 point I have? Negative 5. So where am I going to go?
Down 5.
Yeah, go down on the y-axis, negative 5. 1, 2, 3, 4, 5. And plot your point. Okay, then what am I going to do next, Rhiannon? Well, I'm talking to Rhiannon.
Okay, well, she's not saying anything.
She's saying, I'm giving her time to think. Okay, am I going to go over 4? What is it? Does over describe a term or an adjective for rise?
No.
No. Okay, so what am I going to do?
Rise 4.
I'm talking to Rhiannon still. You hush. Go up 4. Thank you, Rhiannon. And then I'm going to do what, Rhiannon? Still.
This way one?
Okay, which way is that way? If you have a hard time, left makes an L, right doesn't. Okay? Okay, now look, those points are pretty good and spread apart. On your graph, on a normal paper, those points are pretty good and spread apart. So we can go ahead and graph our line there. Yeah. So there's our graph. Yep, always put the arrows on it. Now again, you're always putting the arrows if it says graph a line. Okay, if it says graph a line segment, then it's something different. Do me a favor. Okay, now, this should be pretty easy. Luke, what is our domain? All real numbers. Are you going to use every x value? Is this going to keep spreading out on the x-axis? Yeah, as it continues to go down, because you got to remember, it's infinite. Is it going to keep going this way? Yes. Okay, so all real numbers. Kira, what's the range?
Isn't all real numbers like domain? Isn't it?
Yes, it's the same. So all real numbers is the same as domain. It's going to continue going up the y-axis, and it's going to continue going down the y-axis. Yes?
Is it always going to be all real numbers, or is it?
And that was what the next thing I was going to talk about. Right now, if it's a line, is a line always going to be all real numbers?
Yes.
Yeah, because it has two endpoints that are infinite, right? Go on forever. So lines will always be all real numbers for domain, all real numbers for range. We're going to get into things later on that will have different domains and ranges. Okay? Any questions? Any other questions?